So in this series of videos, we're going to talk about logarithmic functions. Now, in the previous section, we talked about exponential functions. And these two functions are related because they are in actuality inverses of each other. So let's look at that for just a minute. Now, we have said previously that if a function is considered one-to-one, then it has an inverse function, f inverse. And we know from the last section that when we have an exponential function such as y equals base a to the x, we said that that function was one-to-one, and because of our definition of inverse functions, we know if something is one-to-one, then it has an inverse. We also talked in a previous section on how do you find that inverse. We said that, well, in order to compose or in order to find the inverse of a function, we just switch the x's and their y's, or the x's and the y's. So if my exponential function is the one I want to find the inverse of, then I switch the x's and the y's to create the logarithmic function x equals base a to the y. Notice that both of these functions still keep the same requirement here that base a must be greater than 0 and not equal to 1 for both of these things to happen. One other thing I want to point out to you, since we're talking about functions and their inverses, and this will become really important to us a little bit later in the section and possibly in the next one. The domain of our function is equal to the range of its inverse, and the range of our function is equal to the domain of our inverse. So if I know what the domain of my function and its inverse are, then I can find the range of both of those as well. And then remember that if I wanted to verify if something was an inverse, I can compose its inverse with its function to get back x, and it would work in both directions. Now that's kind of a refresher on what it was for a function a function and its inverse. And they're important because we're learning in this section that exponential functions and log functions are in fact inverses of each other. Now formally, I have the definition of our log function written for you here. I took this out of the textbook, and in this particular case, they use a base of b instead of a base a, which I was using a second ago, but it's still the base. So here we say that y is equal to log base b of x, and that's equivalent to base b raised to the y power is equal to x. These two forms represent my log function. This is considered the logarithmic form of my function, and this over here is considered the exponential form of my function. And that's our definition of log functions. So, since we have these two forms of log functions, we want to be able to move back and forth seamlessly between which form of the function we're talking about. So, if I have a logarithmic form, again, the logarithmic form of my function looks like y equals log base b of x. Now, to define a couple of terms here that we're going to be using, y is considered the exponent. B in this particular scenario is considered the base, but anything down here would be the base. And then x is what we call the argument. So this is what the log form looks like, and the exponential form of the same function looks like this. We still have a base b. Y now looks like it should in the exponent position, and all of that is equal to what we call the argument. So let's practice a few examples where we are going to switch back and forth between one form or the other. In the first set of examples here, I want to go from the log form into the exponential form. So I wrote what my exponential form should look like right here. A base of b raised to the exponent y equals the argument x. So if this is the example we're looking at, 6 is equal to log base 2 of 64, I always start by writing the base. The base is 2. We're going to raise that to the exponent 6 equal to the argument 64. So I took it from its log form and rewrote it in its exponential form. Let's try the next one together. Here I have 3 equals log base b of 27. If I start with the base of b, raise it to the exponent 3, all of that's equal to the argument of 27. Okay, hopefully you're getting the hang of this. Here's the next example that I want to look at. I want you to put the video on pause and see if you can come up with the same answer that I'm going to get as well. Hopefully you got a base of 5 raised to the exponent y equal to 125. Okay, so this is moving from log into exponential form. Let's see if we can't go in the opposite direction. This time I want to start with an exponential form and rewrite it in its log form here. I wrote the definition above this. We're looking to change this into y equals log base b of x. Here's the situation that I'm starting with, or the exponential form I have. Base 5 to the 4th is equal to 625. So I start with the base. This is going to be log base 5 of the argument 625 equals to the exponent 4. So log base 5 of 625 is equal to 4. This is the log form. Let's try that again. This time we have this example for you right here. The cubed root of 64 is equal to 4. Now we haven't seen a problem yet where I have a radical in my expression. We want to always start, since we're moving from the exponential form into the log form, right? That's what my directions tell me. I need to rewrite all radicals as rationals. Hopefully you remember that to do that, I start with what's under the radical sign, that's 64, and I raise it to a fractional power. The fraction comes from, the numerator comes from the power underneath here. What is 64 raised to? An understood 1. So that's the numerator of my fraction. And the denominator is the index of my radical. So in this case, 3. So the cubed root of 64 is the same as 64 raised to the 1/3 power. So we have to change all radicals into rational form. Now how do so that's my next step. So I have 64 to the 1/3 is equal to 4. It's this exponential form that I want to move into the log form. So what is my base? My base is 64. So I write log base 64 raised to the argument, or log base 64 to the argument of 4 is equal to the power 1/3. And that's the log form. Again, here's the last one I want to do together, but I encourage you to pause the video and let's see if we come up with the same answer. All right, welcome back. I hope that you were able to see that this is a log base 5 of 125 equal to the exponent -3. And that's how we're going to go back and forth between the log and the exponential